Greetings and welcome, friends. We've been talking about Law of Cosines, and Law of Cosines has a couple strengths compared to the other ones, the other techniques we have. The situations that Law of Cosines is able to solve is side, angle, side, and side, side, side. And just as a quick review of the concept, Law of Cosines looks like this, where I end up with a relationship between three sides and an angle. Actually, this technically is a lowercase c for cosine. Technically. And let's see, this would be cosine of angle A. So there's three variations where if, for instance, if little b is here, then it's A and C in these locations. And so the angle matches the side that's on the outside there for Law of Cosine. So there's some variation. So let's take a look at problem 11 here. So I've got two sides and their included angle. And let's draw a picture of this. Why not, shall we? So picture 51 degrees, something like that, I'm guessing. So here's angle A. B is 7, C is 10. So angle B is somewhere there. Angle C is somewhere here. Something like that. There's my picture. So using Law of Cosines, well, first of all, I just want to point out I can't use Pythagorean theorem. It's not a right triangle. I can't use the triangle trigonometric ratios because it's not a right triangle. I can't use Law of Sines because I don't have a pair of angle and side, right? I need to have that pair in order to get Law of Sines to effectively work for us. So that's why I've got to use Law of Cosines. So the first thing I'll be able to find, I've got two sides and an angle. So two sides and an angle, I'll be able to find my third side is what I'm going to be able to do. So I'm going to say, look for a little a here. So I'll say a squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 51 degrees. So a squared is equal to 49 plus a hundo. Minus 14 times 10 is 140 times cosine 51. I guess I could evaluate what that is. And 49 plus 100 is 149 minus 140 times cosine 51 is 88.10. So then I subtract those two things. 149 minus that is roughly 60.8, well, 90 if I round up. 90. And now I could solve by rooting both sides. Technically, algebraically, I'd have to plus or minus and not forget that. Otherwise, in this case, I don't need it because I'm looking for a distance, and distances are positive, so I can just kind of consider the positive version of this. So A is going to be approximately the square root of that. So I'd get 7.80 as my distance. And now that I've got a pair of side and angle, I can now use Law of Sines to find some remaining information. So for instance, I could find angle B by doing Law of Sines. So I could say, for instance, sine of B over 7 is equal to sine of 51 degrees over 7.80. And I'd get sine of B is equal to 7 over 7.80 times the sine of 51. And then, of course, I would sine inverse both sides. And I'd be able to get my approximated angle B. So that's going to be sine inverse, so second sine of 7 divided by 7.80 multiplied by the sine of 51, double close parentheses. And I will get B is approximately 44.22 degrees. And now if I want to find angle C, which is the last piece of information we're looking for, I can just use triangle sum theorem. So 180 minus A plus B would be the easiest way to do that. So angle C is going to equal 180 minus parentheses, second answer, plus 51, close parentheses. And I get 84.78 degrees. So I've solved my triangle. It's not a bad idea to just kind of look at our sketch. So this is 44 degrees. This is 85 roughly if I round to one place, whole numbers. And you could see that the smallest side is opposite the smallest angle. The mediumest side is opposite the mediumest angle, and the largest side is opposite the largest angle. So it kind of seems like it works out. So not that bad. So that's the idea. We only actually needed law of cosines for the first part, and then I used law of sines and then triangle sum from there. You could use law of cosines the rest of the way through, but I think it typically is more work than the other processes. So I like to solve the problem in some sort of hybrid approach. So here's a situation, a side, side, side. Law of cosines is good for that. And let's draw our little picture. So I'm going to have 12.2, 13.7. Well, no. I'll make the longer one 13.7, I guess. Then 12.2 and 11.4. I don't know. I was just throwing triangles together. So angle A must be the opposite of 11.4. Angle B must be opposite the 13.7, and angle C must be opposite the 12.2. So the sketch, really all of our sketches might look different. If we drew them to scale, they'd all be equal, but they might be rotations of each other, that, different things like that, flipped or whatever. So let's law of cosines this, and how's it going to help us? Well, I've got three sides, and our formula can relate three sides, and then I could use it to find my missing angle. So that's what I'm going to do in this case. So in order to do that, we could, what should we do? Let's find, I don't know, let's find the little angle A first. Why not, shall we? So I'm going to plug in A squared, so 11.4 squared, equals B squared, 13.7 squared, plus C squared, which is 12.2 squared, minus 2 times BC, so that's 13.7 and 12.2, multiplied by the cosine of angle A, my unknown in this case. So I'm going to have to, this being all decimalicious, I'll have to use some calculator here for sure. 129.96 equals, I'll sometimes calculate these next two together. Of course, not adding and then squaring, but squaring then adding, because it's different. 12.2 or 13.7 squared plus 12.2 squared is 336.53. And then I might evaluate this little bunch together. So 2 times 13.7 times 12.2. So this is going to be minus 334.28 times the cosine of A. And now the common mistake is that students want to combine these because these numbers are usually pretty close to each other, and it looks like it'd be easy to combine. However, PEMDAS suggests I have to do the multiplication first, so I can't do that. So what I'd actually end up doing next is subtracting the 336 because I'm trying to get A by itself, so I have to start moving everything away from it. That's like one too many threes there, ain't it? I believe so. What? That is the case, so minus 336.53. So I will get, let's see, 129.96 minus 336.53, and I get a negative number, but don't worry, I'm not scared of that. I'm not worried. And then to get cosine by itself, I could divide by this negative, and whew, that's the good thing. The negatives are going to cancel out here. So negative 334.28, negative 334.28. And I'll get cosine alpha, cosine A is equal to this ratio. Those minus signs cancel out. So let's say I just leave it like this for now. That's one too many decimals. That doesn't work. That doesn't exist. And then to get A by itself, I would cosine inverse both sides. And one of the things we talked about regarding the domain of cosine inverse, as well as sine inverse for that matter, is they only accept values between -1 and +1. So this number has to be between -1 and +1 in order for that to work. Otherwise, your calculator will give you an error, and you'd probably realize you made a mistake somewhere earlier in the problem. So second, cosine inverse of 206.57 divided by 334.28, close parentheses, and I get angle A is 51.83 degrees. All right. So 51.83 is angle A. Let's see, 51.83. And then next you could find angle B, but once I have angle A, you've got a side and an angle, so I'd recommend law of sines to find angle B, which I'm actually not going to take the time to do it out. So law of sines to find angle B, and then step 3, I would try sum to find angle C. But you guys have seen that a whole bunch, and I want to get to the next problem as well. And this is all about law of cosines, so you guys are good at solving triangles from there. So that's what you would do from that point on. But the idea is when you're looking for your angle, you're going to have to just get the cosine alpha or cosine of that angle by itself, and then cosine inverse. And this right here is the most common place where students make mistakes. They incorrectly subtract those when they shouldn't. So let's look at the one last problem here. Here's question 27. It says, baseball. In baseball, dead center field. All right, so they're referring to this location right here. Is the farthest point in the outfield in a straight line through home plate and second base. So imagine, right, this line right there. Bam. All right, farthest distance. Let's see, the distance between consecutive bases is 90 feet. All right, so this distance is 90 feet. This distance would be 90 feet. All right, all of the bases are 90 feet apart from each other. Which actually, question, if this is 90 and this is 90, all right, so those are congruent, what are these angles? They're the same, and what would they be? 45, because this is actually going to be a right angle here. It's kind of hard to see at this perspective drawing, but this is a 45, 45, 90. So if this is 90, question, baseball fans, what is the distance from home plate to second base? It's a special right triangle. How much longer is the hypotenuse than the sides in a 45, 45, 90? Guesses? This distance would be 90 square roots of 2. Yeah, that's square root of 3 is for the going from the shortest leg to the longest leg in a 30, 60, 90. So, so there you go, baseball fans. That's 127.3-ish feet when you're throwing from second base to home plate to get the person out as they're running in. So know your limits and those distances. Good stuff. But anyways, well, all of that little bonus feature was beneficial to at least figure out this angle for me. You might also have realized that this is just going to divide a 90-degree angle in half when I draw that line. There's a bunch of justification for it. But I end up with, of all things, a side angle side situation. So this is side angle side. So then they ask, in Wrigley Field, Chicago, dead center field is 400 feet from home plate. How far is dead center field from first base? So they're interested in this distance here. All right, so imagine, right, crack, the baseball's flying through the sky. You're out in center field, you're running back, and like, oh man, it bounces off the wall, you grab it, and now you're like, I gotta throw it to get this guy out, right? And I imagine he probably could have already ran there in that time, I don't know. And that's the distance we want to know, right? So let's see what that distance is. All right. So to do that, we could label some of our information. I don't know. I could label this. Well, I've been using A for my angle a lot lately. Let's just not use A for a minute. So I'll call this B, this A, and this X apparently. I'll call it C. It could be x. I mean, we don't have to use a, b, and c. Since b is the angle I know, and little b would be the side I'm looking for, b for baseball, I'll put the b squared on the left-hand side of the equation. So b squared is going to equal 90 squared plus 400 squared minus 2 times 90 times 400 times the cosine of 45. Actually, what's cosine of 45 real quick? Square root of 2 over 2 is right. And that's also related to the square root of 2 in this distance, sorry, right here. Completely related to that. So let's see, 8100 plus, let's see, what's this going to be? 16 and then 1, 2, 3, 4. Did I do that right? 400 squared. Yeah, 160 thou minus 2 times 90 times 400. 72,000 times, and then you guys just said it was the square root of 2 over 2. Let's use the exact value for as long as we can anyway. Why not? Right? Because if you're sitting in the dugout trying to calculate this stuff, I mean, you might not have a calculator on you. You probably can only draw on dirt with your baseball bat. And you're trying to figure this stuff out. So let's see. So 8100 plus, let's see, 6160. I'm really worried about my zeros here. Wait, how many zeros? 4 zeros. I already messed up. 8100 plus. All right. That did line up. So 4 zeros, 4 numbers, that can just fit right in there. Perfect. All right. Crazy Mr. Waddy. 1681 hundo minus half of 72,000. What's that going to be? Is that 36,000? Square root of 2. I believe that cancels out that way, right? Half of 72 is 36. I'm getting no feedback here. You guys are making me nervous. Let's see. B squared equals. I'll subtract this out. Let's go to the decimal place now. I can't subtract those numbers before I multiply, is my point. So this minus 36000 times the square root of 2 is equal to roughly 117188.31. And then, of course, I would root both sides to solve. And we would find that b is equal to, or approximately, the positive square root. That's why I'm only writing the positive. 342.33 feet. Not too shabby. Not too shabby. Right? So, good stuff indeed. Being able to calculate that, law of cosines. And now I believe you guys have been equipped with all of the skills necessary to solve any triangle that's solvable, at least when it's on a two-dimensional plane. So congratulations, ladies and gentlemen. If you finish this quiz and test effectively, you guys will earn your triangle badges and can move on. It'll be great. So have a good day, everybody. Thanks for watching. Bye-bye.